All right, now we're getting into section 9.2, which is the fun part of looking at graphs and how different they look compared to our normal coordinate graphs. The first thing we're going to do is notice that here, instead of just a regular grid, we have what's called a polar grid. And there's some key features of this that you're going to have in every grid that you have. Of course, the center is going to be your pole, right? We talked about that as a vocab term. And then, of course, this is your polar axis right here. So that positive x-axis is going to be your polar axis. Now, just because we've got that does not mean that we still don't see an actual coordinate, right? So when we were looking at stuff before or graphing stuff before, I had you doing it on just kind of like an XY plane, um, but it's the same type of thing. Each of these circles that you see here is, in this case, 1 unit away. So this first one would be the equivalent of your unit circle. And then this would be 2, and then 3 and 4, and finally this last one here would be 5. And you can tell that because it's got, erase this here, it's got all that information right here for you. R equals 1 is that first one. They skip 1, R equals 3, and then R equals 5. So they're giving you all the dimensions that you need. In addition to that, it has your quarter markers. So pi over 4. That means that this is pi over 6, and this is actually pi over 12. And then this would be pi over 3, and this would be 6. That'd be 5 pi over 12, right? So it gives you some of those markers so that you know where you are. All right, let's go ahead and plot our first one. Our first plot point is 5 pi over 4. Remember, 5 is going to be how far we are on the number line, right? So we can consider this our number line. So we're at 5, it's that outer ring. And then we're looking for pi over 4. And pi over 4 is right up here. So I'm going to put a dot there where we have um, where we have 5 pi over 4. And I'm going to go ahead and label that. Oops, didn't mean to take it out. I'm going to label that 5 pi over 4. Okay, so that's my polar coordinate. And then this one, I'm plotting -2, 5 pi over 6. 5 pi over 6. So normally that would be, let's see here, 5 pi over 6 is this one. 5 pi over 6. And, oh, we've got a -2. So we're on the second band, right, because it's number 2. Um, however, however, with that negative sign, it means we have to go all the way over onto the other side, right? So where I'm going to connect is going to be right here. So this will be -2 5 pi over 6, right? Because remember, I go normally with 5 pi over 6, but because I have that negative sign, that means I have to change direction and go this way. And then I skipped the first loop and I went to the second loop because my value was 2. All right. So that's really that's all there is to it with graphing on a grid. All right. So the last time we went through stuff, remember how we had um, well, if we do 5 pi over 4, and I believe that we did that as one of our example problems on the last section, I can approximate that on um, in decimal format, right? So 5 root 2 divided by 2 is about 3, oops, let me change to a pen. It's about 3.54, and of course this is 3.54 as well. And then -2, 5 pi over 6, um, we got to square root of 3 and -1 on that one. And that is about 1.73, and then of course -1. All right, here's where we have our grid, our rectangular grid on top of our polar grid. And let's go ahead and finish out this one too. So negative 3, 3. We said it was 3 root 2 over, and 3 pi over 4. So my rectangular version of that is going to be 4.24. Well, this is my rectangular, but I'm converting it into decimals. I'm going to keep 3 pi over 4 because that's actually a really easy thing to find um, on our grid. All right, these are all different colors, so I'm going to go ahead and do this first one. Okay, if I have um, 3.54 and 3.54. I'm going to first map out this, okay? So 5 pi over 4. So 1, 2, 3, 4, 5. Pi over 4 is right here. So this is 5 pi over 4. That's my the way that I do it on my polar graph. And then if I'm looking at that grid that's on top of it, I'm looking for 3.54 and 3.54. So here's my grid, right? 1, 2, 3. It lines up with my rings. But I have 1, 2, 3, right? So that's 3. And this is 3. And then I go up 0.54 and 0.54. And sure enough, it's going to give me that same value looking at it from the rectangular standpoint. Okay. All right, I'm going to switch to red. So we can do negative 2, 5 pi over 6. So negative 2, 5 pi over 6 we said was right here. So negative 2, 5 pi over 6. That's what we just graphed right up here. Okay, so I'm just transposing that graph down here. And let's see here. If I have 1, 2, am I here under, I'd say like 1.7 something on my x. And yep, 1.73, so that jives. And then negative 1, here's 1, here's negative 1. Yep, so that rectangular piece for sure matches all of my polar stuff. Okay, so the rectangular piece matches all of my polar stuff. Okay, and it just says verify that the answer is correct. So far so good. Last one is going to be green. Um, that one we had um, our rectangular, and then we were moving over to polar. So I'm going to go ahead and graph negative 3, 1, 2, 3, and positive 3, 1, 2, 3. So this was my piece. And now it wants me to find out, well, we know that this line right here is 3 pi over 4. So we've got that going for us. And our ring is 1, 2, 3, just a hair over 4, maybe a quarter after. Sure is. Looks like it. So whether you're given the rectangular coordinate or the polar coordinate, as long as you know which is which, you can graph anything and it will actually work out on either axis depending, or either grid depending on which one you're doing.